So top quiz 17, which is related to organic chemistry questions. And the first question is about propene and some related compounds. Some reactions of propene are shown. As you can see here, reaction one, in which a propene is converted into propane, and reaction two is there when propene is converted into propanol, and with acidified potassium manganate, it gives a product B, and with chlorine, it gives a product A. Identify by name or formula the catalyst needed for reaction 1. So which catalyst is needed? We use nickel as a catalyst. Platinum is acceptable, but nickel is the right catalyst for this. So we use nickel as a catalyst. Here we can write a name or a formula. So we can write Ni, or we can just write the spelling for the nickel. You have to learn the catalyst for a reaction. For alkenes, this you have, because they're fixed, so you have to memorize this catalyst. Name product A. So what will be a product A? Because you have propene. So this is a propene. And a propene is reacting with chlorine. For alkenes, it undergo addition reactions. What will happen when propene is reacting with chlorine? The double bond will break, and these two chlorine will be added to each carbon, like first the two carbon atoms which were having a double bond. So when the double bond break, it turn into a single bond, and the two chlorine attached to the carbon which were having a double bond. So what we call this compound? First position and the second position we have chlorine. So we say 1, 2, because first and second position we have chlorine. So we say 1, 2. There are two chlorines. So what is the term used for two? This will be di. And what we use for chlorine, we call chloro. So 1, 2 dichloro. And because the double bond has turned into a single bond and there are three carbon atoms, so it will be prop because of three carbon atoms. And throughout the structure, they have a single bond, so it will be N. So it is 1, 2 dichloropropane. That's a product which is formed. Identify by name or formula the substance needed for reaction 2. Here, what we need for reaction 2, we want to convert into alcohol. So if we want to convert into alcohol, we need steam. And we also use a catalyst for this reaction. What is the catalyst for this reaction? We use phosphoric acid as a catalyst. So H3PO4, phosphoric acid is a catalyst, and we need steam. Or it can also be done by adding first concentrated sulfuric acid, then followed by water. So again, this is related to memorizing, like how certain alkenes converted into different types of compounds. So reaction 2, we need a steam, and we need phosphoric acid as a catalyst. The next is draw the displayed formula of the product B. What will be the product B? Remember, whenever we use acidified potassium manganate, KMnO4, it will changes from purple to colorless, and it will produce diol. What does diol mean? The term diol means like the double bond turned into a single bond and two OH groups are attached to the carbon. So propene is like C double bonded with C, This is propene. But when it turns into a diol, the double bond will break down. In a diol, the double bond turn into a single bond, and then this will be OH, and this will also be OH. So the carbon atoms which are having a double bond will turn into alcohol like diol. So we have to draw displate. Displate formula. When they say displate formula means you have to show all the bonds and all the atoms. If it was a structural formula, we don't have to show all the bonds. But in a displate formula, you should represent all the bonds. So first, propene will convert into propane, like the double bond turn into a single bond. And then what will happen? The OH will be attached. Here the OH will be attached, and this also the OH will be attached. Then propene can undergo addition polymerization. Write equation for polymerization of a propene. Here we need equation. So what will the equation? For equation, you have to write the reactant and the product. So whenever you draw, because monomer will turn into a polymer. So what is the monomer here? The monomer is propene. And what is a polymer? The polymer will be polypropene. Like many propenes together, that will make a polypropene. How the monomer should appear when we represent the addition polymer, the monomer should appear like letter H. So C double bonded with C, two bonds up and two bonds down. Because it's a propene, so 1, 2, and 3 carbon, so this will be CH3. And this will be H here, and H here. This is propene. Instead of drawing the structure in this manner, we show like letter H. Now it has to form a polymer. So if we have N molecules of propene, the double bond, the same structure you will draw, the double bond will turn into a single bond and put a bracket, then write N. Because this is an equation, so whenever we say equation, so you must write the reactant and the product. Because equation involves the reactant product. So reactant changes to product. If we have N molecules of propene, it will turn into a long chain compound, which is known as the polypropene. The next is over 70 million tons of polypropenes are produced each year. State two problems with the disposal of the polymer such as polypropene. So what are the problems related to these addition polymers which are non-biodegradable? So many of these polymers are non-biodegradable. So what will happen as a result? It will increase the size of a landfills, like dumping grounds. We have to use a large area to dump these polymers. And the second thing, they are not most of them, the addition polymer, not all, but most of them are not cannot be recycled. So most of them cannot be recycled. So as a result, what will happen again? Um, we have to separate the polymer which can be recycled and which cannot be. Like separation should be done. All of them cannot be recycled. Same thing, the incineration or burning of these will release toxic gases, can cause like toxic gases will be released to the surrounding. So you have to just state the problem with the disposal. So first thing, most of them are non-biodegradable. So what is the effect of non-biodegradable? This will result in increase the landfill sites and cannot be recycled. So what is the effect of cannot be recycled? So we have to carry out like separate from other polymers which can be, so separation should be done. Separation of the polymers is also needed. And then burning of these polymers, if we want to overcome, so if we burn them, this will release the toxic gases. The next is hydrogen bromide react with 3-bromopropene to form 1,2-dibromopropane, the major product. Complete the mechanism to show this reaction, include a curly arrow, any relevant lone pair, and the dipoles. So how we can represent this? As I mentioned in the mechanism, the reaction mechanism, the side which is facing the carbon-carbon double bond, that because this electron pair experience greater repulsion from the carbon-carbon double bond, so that causes shifting of the double bond. As a result, hydrogen will be partial positive and a bromine will be partial negative. Don't write plus and minus, like it's not a full positive and negative. You have to show partial positive and negative. Then how we represent the, so as a result, the electrons are shifted towards bromine, and this hydrogen, which is partial positive, is attracted towards the electron pair. We always represent the arrows from the electron carbon-carbon double bond to the partial positive side. This is how it's done. Then what will happen? The double bond will break. When the double bond will break, the hydrogen will be attached. Which side the hydrogen will attach? Because two possibilities are there, but we want a product of 1,2-dibromo. So we want this because 1,2-dibromo means like first and second carbon have bromine. So when we break this, when the double bond will break, like two possibilities. When I break the double bond, this one is hydrogen here, this turned into a single bond, and then this hydrogen, and then Br. Now I have two possibilities. I can attach hydrogen with this one, then this will be positive. But if I do like this, then it will be 1 and 3 because the bromine will be attached, like the bromine, the bromide ion, which is having a lone pair. So that will be attracted toward this carbon. So this will produce 1,3-dibromo because first position and the third position I will have bromine. So it means it cannot be because we want a product to be 1,2 as given in the question. So to have a product 1,2, the hydrogen will be attached with the first carbon and this will get a partial. This will get a complete positive because it lost its electron. And then the bromide ion with a negative charge attracted towards a positive, and the final product will be, so the final product we have CH, H, we have H here, Br, and then this was a hydrogen. Here's a hydrogen was there, and then the bromine attached here. So you can see it's 1,2 because first and second carbon have a bromine. So it's 1,2-dibromopropane. Is it clear, this mechanism? So it's always the same, that the part of a molecule which faces the carbon-carbon double bond will have a partial positive and the other part will be partial negative. And the electron direction from the carbon-carbon double bond to the partial positive. Then explain why 1,2-dibromo is a major product instead of 1,3. Like why we have as the same reason for this one. This is also a common question. Like they ask which is a major product, which is a minor product, and why it happened. Like what are the two possibilities if we have this structure? If we have this structure, so when the double bond will break, like this double bond will break down and turn into a single bond. So one possibility, this will be this will be a carbon positive cation and then hydrogen. This carbon cation is surrounded by two alkyl groups. But the second possibility, if I draw the same structure, if a hydrogen is attached to the if hydrogen is attached with this one, then what will happen? This will be carbon. This carbon cation is surrounded by one carbon chain. But this carbon cation is surrounded by two carbon chains. So this will be more stable, or this will be a major product, and this will be there, but a minor product, small quantity. So what is the reason for that? The reason is when carbon cation is surrounded by alkyl groups, that is more stable because alkyl groups are electron releasing group. So when they release the electron, like they reduce this net when we say electron releasing means they're not able to attract electron too much. So this electron is shifted more towards the carbon cation. So the partial positive sign on the carbon decreases. Or you can also say, like this is called, when carbon cation is surrounded by two alkyl groups, this is called a secondary carbon cation. And when carbon cation is surrounded by one carbon chain, irrespective of number of the atoms, but only one side the carbon is attached, we call that as a primary. And secondary, like tertiary, and there is also tertiary. Tertiary means like three carbon chains are there. The tertiary is more stable than secondary, and secondary is more stable than primary. So you can mention here the carbon cation surrounded by more alkyl groups is more stable because alkyl groups are electron releasing group, which reduce the charge on carbon. So as the charge reduce, it won't react quickly. If a charge, if a greater charge is there, then the rate at which this will react, that will be much higher. So this was the organic chemistry pop quiz, which was pop quiz 17 related to organic chemistry.